everybody. On week 5, yes, week 5 of C++ Londonini. My name is Tom, and before we go, there is a warning. This is a very dangerous class, so be very careful. So there is no fire test planned for today. If you spot or smell fire, just run. Sorry, don't run. No, don't run. Go to the nearest exit, follow the arrows. Probably. You can't walk. If you can't walk down the stairs, wait near the lifts. But lifts don't work. Yes, they stop in event of the fire. If you are hurt during our exercises, reception is very good at providing first aid. Not sure if they will remove the compiler, but they will definitely give you some plaster. So that's the.
Please don't hurt the people at reception. Don't
Yes,
that.
they have nothing to do with us. So. Our group, the charity group, is run by 3 people. Well, maybe more. So me is there, Ollie with the hat, and Tristan, who is today enjoying beer in Belfast. So he's the lucky one. And obviously, thank you first of all to University of Law for providing us with the space. Yes, we can do that because they are generous to us and they're helping us. But as well, our group wouldn't be able to exist without these people. Basically, these people make sure that we receive extra money, a couple of pounds every so on, so we can buy equipment like mics and so on, so the quality of what we do can be recorded, streamed online and so on. So if somebody wishes to review the classes and so on, they can as well apply to you. Everybody pretty much got the Wi-Fi access. If not, by now I memorized the password, so I can give it from the memory, so we should be okay. We are getting to the end of the introduction, and we'll move to the module 2. But for that, to get the details, and with regards to further modules, basically soon we will have the details, because basically we need to agree the details, what will be done and how. The idea is basically from January, University of Law asked us to restart course as well, so the new joiners can basically start with us. But obviously we want to do it in such a way so you can still continue, so you don't have to go through the early stages, like, setting up, the sea lion, writing the first hello world, and so on, so it will be interesting for you. So we're trying to work out how to do it, so you can still learn something new, but as well new people can potentially join. So we will be hopefully discussing this this week. So the lesson, is there anybody new? Okay, so I'll explain. So basically the class, our way of teaching is pretty much divided in a week into 2 parts. Part 1, which is today, it's to present the knowledge. But basically what we worked out during the previous courses, it doesn't work if we try to do the exercises, like a longer exercises during the class. Basically it takes too much time. There's too many people. By the time we manage to do even a simple test, it's too much time gone. And basically lots of people will get bored, so the progress was quite slow. So what we decided to do is a very clever chap, either Oliver, Tristan, or a guest tutor will do the explanation of the subject, but then actually the practical part is on Thursdays. Now, if you do attend the Tuesdays but you miss Thursdays, you're shooting yourself in the foot, because you are having pretty much one-on-one with experienced developer. Stuff like that costs normally a few £100, yes, per session, because their time is very expensive, and you're getting this for free. Yeah, so it's happening here on Thursdays. So you sit down there, you can do the homeworks which we assign you on Tuesdays. You can do other projects and so on. So it's a really valuable time. Yes. So if you want to accelerate the knowledge, you want to move faster, pretty much go to Thursdays as well. Because when this guy finish explaining, all what he said will be dead simple. It will be, why? Where's the scary part? Yes, C++ is not scary. It's easy. I don't see a problem. But when you sit in front of the IDE and you have to then recreate, and there is so many variations and changes, it suddenly becomes much more challenging. And this is the part where actually you get the experience. So do join us on Thursdays as well. If anybody of you need a license, start by going to JetBrains website and then sign up. If you're in a full education, you can get full year pretty much for free. If you need a license, I have for our students. This is a commercial product, but I have from our friends at JetBrains a license, 6 months license for our students. So ping me an email with your name and with your email address, obviously. And I'll be able to send you the license. After the class, we always go. Sorry, I went slide ahead. So basically, what we need is because as you know, we're free. We don't charge you any money. The knowledge is valuable. These guys spent years learning that stuff. So we need a little bit of support from you. Yes, to make this project, because nobody will come. If I have 2 people, yes, or 1 person coming, the experienced developers will not bother turning up because they will say, why? Why should we? So I need some help from you as well. The help which we asking you for is basically help to get in touch with new people, somebody who wants to learn. Because for us, it's a pleasure. We can help somebody, give them an opportunity they didn't have before. So you can help us by passing the message. If you know somebody who would like to spend some money, let them know. Share about something about us on social network. If you benefit from our class, subscribe to Patreon, where you can pay a couple of pounds equivalent for coffee or 2 a month to pay towards us, so we can basically buy equipment. But as well, this is my personal appeal to you. If you enjoy the class, these guys, they had to spend pretty much, almost a day preparing and running the class. So when we finish the class, it's a good idea to go to the pub and just buy them a beer or 2, maybe a hot meal, so they go home, fed and with a couple of drinks. So they say, actually, it's worth it. Yes, these people, I look after them. I am passing my knowledge, experience. In return, what they do, they get me a couple of beers. So all my day of hard work is pretty much not for nothing. So I would encourage doing that. And obviously, do check the website. If there are any changes, I will basically put it there. Something which probably you may not be aware, but some of might. Our previous house, called Skills Matter, which is just a few doors down, just closed down, unfortunately. They went into the administration. So if a situation like this happens, if I had to communicate now, at the moment we have, 40 people in the room, but we got on our list something like 800 people. So I don't know which of the 800 people, how many will come. So to get message to all of these people is quite challenging. So do check our website, because that's the only way I can actually relay the messages to you. So that's all from me, and I'm passing you to much cleverer, smarter guy, and he will tell you way more interesting stuff.
Okay, yes. So let's get these slides going then, yeah. So if it plays nicely with me, we should be good to go. Okay, excellent. We are on, Tom. Just a quick check on the stream. Is it looking all good? Brilliant. Okay, cool. We're live. Lovely. Right. So as usual, the obligatory feedback slide. No, not the obligatory feedback slide. It's decided to jump all the way over here. There we go. Obligatory feedback slide. As always, we do love to hear from you. If you're not already on Slack, why aren't you? It's a great place to converse. We're all on it. If you need help, if you want to help others, either way, go on there. There's a bunch of channels. We're not the only people on it. We don't run the Slack. It's provided as a community thing for free. We happen to have a channel on there. Wonderful resource. Many, many people on it. Get it. It's free. So, first, I just want to recap, over the bits of the previous lesson. Most of you are here, right? I think there's just a few at the back who haven't been here before. So, essentially, last week we covered, first of all, loops in C++. So, obviously, the first one was a while loop. So, while some condition is true, execute some form of statement. Once the statement is no longer true, stop doing it. Obviously, a subset of that was do while. So in the event that you want to unconditionally execute something at least once, you can have a do while statement. So it will always evaluate everything inside your do chunk, as it were. It will then evaluate the while statement, so it's guaranteed to run at least once, even if the while ends up being false the first time it checks. And of course, then we had the for loop. So who can remember the for loop rather than me just spouting it out? Anyone? No? No takers? Okay. Oh, yeah, okay.
Should I say the code?
Just give me the stages if you like.
Okay, setting a check variable.
Yep.
Then having a condition, using the check variable, and third part, incrementing the check variable process.
For example, yes, absolutely. So it's comprised of 3 parts, or composed of 3 parts. You have your initialization, the first part. You have a semicolon to separate it. You then have a condition that you check, or a series of conditions if you like. And then finally, you have some post-iteration operation, which in what we looked at happened to be an increment. But it could effectively be anything if you liked. And of course, we then looked at the sort of the new modern brother, or sister if you like, of the for loop. It's the range-based for loop, which should be very familiar to those of you who know either C# or Java. It's a convenient piece of syntactic sugar to make your life easier when you're iterating over containers, such as a vector, which we also used. We then looked at, very briefly, the break statement. So who knows what break does inside a loop? It takes you out of the loop, or it terminates the loop, essentially. Yes, exactly. And continue. Yes. So continue will skip the rest of the code you would otherwise have executed in that particular iteration, and it will move straight to evaluating the condition to see whether or not there is more looping to be done, as it were. Is that all clear to everyone then? Yeah, cool. So in last week's homework, you were asked to write a program which reads a sequence of strings. Is there a laser on this? No, there's not. Oh, there is. Oh, no, it doesn't work. Never mind. Okay. A program which reads a sequence of strings from the user with std_cin. So obviously std_cin lets you get user input. They can type stuff on the keyboard. And then store it in a std vector. Who remembers what a std vector is in its essence? Nobody. Yeah, okay, one at the back again.
A collection of variables of the same type.
Exactly. It's or a collection of items, we'll say, right? All the items must be the same type, and it allows you to group them together. You can and it dynamically gets bigger or smaller depending on if you put stuff in or take stuff out when the program runs. So obviously, once we'd read them all in, as we were reading them all in, we were supposed to keep putting them in the vector until the user entered the word quit. Obviously, we didn't want to include the word quit in the vector, so you were supposed to detect this and bail out to ensure that you didn't actually log it, put it in the vector, that is. So after they've typed quit, you should then go over every element in your vector, and providing it doesn't start with the letter B, you can print it out to the screen. So, for example, if we had the input apricot, banana, cherry, date, and finally quit, so they're entering each word at a time, pressing enter, then we would expect it to print apricot, cherry, and date, because banana begins with a B, so we don't want to print that. And obviously quit is the special keyword, which we're not supposed to put in the vector. So here's a possible solution to the homework. And actually, who out of interest has done this one and got it all working as described? Yeah, brilliant. Okay, very nice. Well done. So obviously we need our headers, right? We're including IO stream because we need to be able to use C in and C out, including string because obviously strings, we need a string. And vector, of course, which is going to collect everything together. So we have our main function. We'll then declare one variable. This will be used to store the input from the user sitting at the keyboard. We then have our vector of strings, which obviously is going to contain all of the items. We then have a loop. So I've bundled this operation together. So while we successfully read in an item, because obviously this operation here will return true or false. And as long as item doesn't equal quit, right? Because if this somehow passes but they type nothing, it would be empty. But actually, well, that's not allowed. So essentially, once that's, as long as it's no longer quit, we'll log it. And of course, we can just push it back in. So does that make sense to everyone? Read in the user input, check if it's not quit. Providing it's not quit, in it goes. Yeah. Then we're going to iterate over it. So obviously we have to declare the type. So there's obviously, stood string here, so it has to be stood string here. So for each item in the items container, our vector, if, first of all, we have to check that it's not an empty string, because if it's an empty string, we're not allowed to actually try and access any of its characters because it doesn't have any. So we first have to make sure it's empty. Then we're just going to make sure that it's not the first character. Again, this is 0, 0 based, right? Everyone remembers from last week that indexing in C++ is 0 based, right? The first element is 0. Yeah. So we check if it's okay. Hopefully that's fixed it. Let me just purge that there. I need new batteries. All right, bear with us, folks. Just replacing. So if I was doing it with numbers,
If you type 1, it will convert into string 1 and tell 1 to reject that.
oh, I see. So the options would be I could check for just the character one, right? There is a bit of math you can do to convert ASCII digits back to their actual integral value. And that is that you can AND them with the value, it's not 0x30, what is it? 0x10? No, not 0x10. How many bits do you need? Anyway, you could. There's a value. If I looked at the binary, I'd remember. But essentially, you can AND the char, and it will turn a 9 character into literally the number 9 in the CPU. Obviously, you should do some validation. If it's a character like F, you're just going to get garbage out. So you'd have to do some checking. But yes, if you happen to have a digit converted to a character, you can just compare the character values. Obviously, it's effectively the same. So moving forwards, right, we're going to talk about the auto keyword. And since we've restarted, that's great because I get to reuse quotes I've used before. C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, you blow your whole leg off. And that's a wonderful quote from the inventor of C++, Bjarne Stroustrup. So, we're going to talk about automatic type deduction, which I'm sure that sounds very intimidating and difficult, but it's actually a really simple concept. So, obviously so far, we've been explicitly stating the types of all of our variables, right? We have an int x, or a string word, right? We have all these types that we put in front of our variable names. For example, we could have this loop, right, for string word in words. So harking back to the solution to last week's homework, we had a range-based for loop, and obviously words was a vector of strings, and word was each element, because obviously it's each element is a string. Right, fine, easy enough to understand. But actually, we can make the compiler do all this for us. The compiler can figure that out. And the way in which we leverage that feature is with yet another language keyword, which is called auto. So in the same way we have int and float, etc., we also have this keyword called auto. So, if we take the same loop as here, and we use this auto feature, we can simply write this instead. And that's quite useful, right? Because if I have a vector of string, then obviously both of these are fine. They'll both work. If I have a vector of int, well, the top one's not going to work anymore because it's no longer strings. It would be a vector of int, so I need to change that to int. But this will continue working flawlessly, right? The compiler will deduce that the underlying type is an int, and it will say, OK, well, you're an int, right? The type is still fixed in place. It figures it out for you, but it's still set in stone once it has figured it out. In the same way that this is set in stone as being a string. You can't make word not to be a string, right? You could make a new variable and do some conversion, but this variable is a string. And the same rules apply even when the compiler has done the deduction for you. So as I've said, you get exactly the same behavior, exactly the same code, but it's a little bit more generic. So, well, let's have a look at some examples of auto, yeah? So, we'll create a main function. Simplest one first. AutoX equals 53. So again, the compiler is going to look at this code. It's going to look at the right-hand side of the assignment in order to do the deduction. And it sees that you've got a number here, which is 53. Well, 53 is an int. Therefore, the compiler will deduce that the type of x is int. And it's exactly the same as if you had just written int x instead. Does that make sense? Yeah? Cool. Decimal place. If you did 53.4, it would become a double. If you did 53.4f, it would become a float. So we can then, of course, deduce from other variables as well, not just literals, right? So we now have auto y. Again, it's going to look at x. X is already figured out, right? It already sorted that out up here. Well, x is an int. Y is also going to be an integer, an int. Makes sense? No confused faces. Looks good. OK. So now we can obviously leverage it in the way I described on the previous slide. We have our vector of strings, right, which is words, and we now have a loop over them, right? I don't have to write string anymore. It's deduced for me. And for each element, we can print them out. Again, it's still a string. Doesn't do any additional magic. It just figures it out for you. So let's talk about a few caveats to the auto keyword. First of all, it needs something it can deduce the type from, right? So in the case of what I just showed you, you had either the right-hand side of an assignment, so we can figure it out because the right-hand side of the equal sign is some concrete value, or it was able to figure it out in the for loop because it looks at the vector and it knows that every element of the vector is a string, right? That's already set. It can see that. So consequently, that means that if I just write auto x, that won't compile because there is nothing there to figure out. Does that make sense? Stop me if not. No, good. So if there's nothing to refer to, it just won't compile it. It's like, well, auto what? What should I deduce auto to? You've given me nothing, so it won't. So it has nothing to do, cannot compile. Your code will not work, will not build. This also has a really nice and useful property, because if I had written int x there, would that compile? If I replaced auto with int, would it compile? Yeah? Because there's no type to deduce. But then I have a variable that's uninitialized if I were to do int x, right? If I tried to read that, well, that's undefined behavior, right? The program will compile, but attempting to read it without giving it a value is something you are not supposed to do. The computer will let you do it, but it's effectively garbage code at that point. So by using auto, I obviously can't forget to initialize it because it won't compile if I haven't initialized it. So this has a very, very handy property in terms of actually initializing or making sure that you initialize your variables. However, an additional caveat. I probably should have separated this because I was going to ask the question, but I've kind of given it away. So does anyone know why that won't be std string? Yeah, well, you know. I'm sure, yeah, you know. Anyone else understand why that's not a std string? And this is actually something I wanted to bring up to you because obviously if you do start, I do encourage using auto, but this can catch you out. So the reason why is because the type of a double quoted, this string literal as we call them, the actual type of it is const char star. And don't worry about it at the moment. Just be aware that that's a thing inside C++. When you're using std string, it has these handlers that will convert this const char star thing to the correct std string type for you. So under the hood, there's actually a conversion going on. So don't worry about what const char star is, but just be aware that if you use auto with a string literal like this, you're not actually going to get a std string, probably not what you're expecting. So the basic advice here is if you are dealing with any kind of strings, you probably do want to continue using std string instead of auto for now. And again, auto it's for your convenience. It's also there for some degree of safety, right? As I said, it will prevent accidental non-initialization of your variables. Yes.
Why did you write as auto str and why did you say auto? Oh, okay, it's a variable name.
You have to give a variable name, yeah. You can just have auto, yeah.
And then you couldn't use auto when you initialize the vector in one of the examples. You had to still specify the vectors.
If I go back a sec for you, so for example, yeah, so as an alternative way of doing the exact same thing for the vector of words is you could do auto words equals std vector, std string, and then either circular or curly braces, so parentheses or curly braces. That would do the same thing. You'd end up with, the vector of string of words, a vector of strings called words. So, right, we're through with that. Yes.
So what would be the difference between const char and std string? They will have different attributes. When you run the program, functions, what's the effect?
So a std string is provided by C++'s standard library. It's a really nice object type that gives you all that nice, functionality of asking for its size and asking if it's empty, right? Const char star is just this extremely primitive thing, right? It's essentially a built-in type. So int is a built-in type. Char is also a built-in type. So what we have is a pointer to a chunk of effectively raw memory that happens to contain the values of those 5 characters, plus an invisible one that's a 0 at the end. Whereas if you use std string, everything's all wrapped up and it's nice to use. So that's why I'm saying when you're dealing with strings, you probably just want to stick to using std string rather than auto for now. This const char star has there's no methods, there's no functions you can call on it, right? I can't call dot size on a const char star or any of that stuff. So let's do a bit of quick revision on value semantics. So obviously in the absence of any qualifiers, and don't worry if you don't know what qualifiers are, they're something that we're going to, be getting into real soon. But in the absence of any qualification, C++ essentially uses value semantics, which approximately means that every, copies of data, right, each variable being a copy of data, is distinct, right? If I make a copy of an int, I have int x and int y. If I modify y, it doesn't affect x. And the reverse is also true, right? Modifying x does not change y. They are discrete, unique objects. However, that does also mean that copies in C++ are deep. So if I have a std vector of string, or a std vector of int, whatever, if I make a copy of that, so we have x and y, but they're vectors, then every element must be copied to the other variable, right? All that memory has to be copied over. So you can imagine if you had a vector of string and a massive amount of nesting, it could get potentially quite expensive, and we'll explore that shortly. All fundamental types, right? Int, float, and all the library types like string and vector, as I've just mentioned, right? They all have this concept of value semantics where you're just copying their data, right? Of course, some other languages do have somewhat differing behavior, right? So are there anyone here know Java or C# by any chance? Got one. Okay, so if you are familiar with those languages, this is probably more for those watching at home. If you are familiar with Java or C#, you'll know that you have the concept of primitives, which is, int, float, long, etc. And then reference types, which is your sort of classes in those languages. Well, we don't have anything like that in C++. We have a nice, consistent experience. There's no magic. We don't just sort of shallow copy stuff because it's a reference type or some, let's say, irritating behavior like that. So let's just get into a bit of code, right? It's the best way to explain. So, we'll have our main function as usual, and that's pretty simple, right? We have int a equals 1. And then we can assign the value of a to this new variable we've called b. So everyone is clear that at that point we have two unique, unrelated objects, right? They don't share memory, they're not sharing anything with each other, they just happen to both be set to 1. Simple enough, yeah? So now I'm going to change a to 42. B is still going to be 1, yeah? Because they're separate. Same again, we'll have a string class. We'll put the word hello in it. We can then have another string that's got the word world in it. If I use the plus equals operator, so that's the concatenate, append if you like, we're going to stick s2 onto the end of s. So s, the top one, will be hello world, but s2 will be unchanged, right? We're reading from it, but we're not actually modifying it. Again, tautological, I hope. Yeah? Has everyone got it? Cool. So let's just talk about that as what we call pass by value. So obviously, generally when we call a function, whether it's our own or whatever, usually it's going to be taking a copy of the arguments we pass. So when we invoke it, when we call it, those arguments are copied. The function can play with those copies, but when it returns back to us, we won't see any of the mucking around that it actually did, right? We gave it a copy to play with, and we're not looking at it. We don't care, right? It's private to that function. And this is what we call pass by value, right? We say, here are some values, right? We usually have some existing values of our own, but because we're saying, right, you are getting a value, we will have to copy whatever we have so that it has them independently for itself. Make sense? Pass by value is effectively when you copy. Yeah? Cool, okay. So each value in turn is going to be copied into it, to the particular parameter that it is. Of course, as I was briefly saying earlier, well, there's a caveat to that, right? If I have a function that takes a vector of strings, well, okay, if there's 5 strings, each string's 5 characters long, that's about 25 bytes, right? It's not a lot. If it's a vector of 1,000,000 strings, and each string is 100 characters long, that's now 100 million bytes we have to copy. By modern computer standards, probably not going to take that long anyway. Computers is fast. But as the numbers get bigger, it's guaranteed to eventually get slower, right? If I had a vector of 1 gigabyte of data, that's a whole gigabyte of your computer's memory, right? And if I then have to copy that just to call a function, my program's just now gone from eating 1 gigabyte of your RAM to 2 gigabytes of your RAM. And then, of course, only after we come back from the function can we at least free up one of those 2 gigabytes. And, say 10 million elements, for example, right? It could take an inordinately long time, right? Which is going to annoy the user. It's a bad experience and probably a waste of memory, right? If all we're going to do is read from the object inside the function, we didn't really need to make a copy of it, did we? We could have just, well, actually, we're getting to it. So, first of all, just remember, when we initialize a variable, this is also value semantics, the same as passing arguments, right? If the argument is int in a function, it works the same way as just doing an assignment to an int. It's a copy. Makes sense, yeah? Am I going too fast for anyone? Hope not. I've lost everyone. So everyone's clear on this concept that it's copying, right? They're independent. The variables are independent, and you have a copy of some value, yeah. There is a lot of typing. Yeah. Does anyone need me to wait a moment?
I mean, if you have a question and you're not sure about something, just ask, because for them that's daily bread. And if you have a question, I bet the other person have as well. They just shy to ask the question.
Don't be afraid to speak up if I'm going too fast.
I believe I'm probably one of the biggest idiots who doesn't understand, so I do ask. Don't worry, I beat you, so you can ask the question. Don't worry.
Please don't be afraid to speak up. Okay. So now we're going to talk about the concept of reference semantics. So we have value semantics, right, which is copying. We have reference semantics, which is probably unsurprisingly not copying. But let's describe that in more concrete terms. So essentially, instead of creating a new copy, so when we have int x, we can append an ampersand, the little and symbol, onto the end of the type. So in the case of int x, it would be int ampersand x, right? And that would tell the compiler that we want a reference instead of a copy. A reference type is essentially creating another name, an alias for something that already exists, right? So you now have two names, but they are in fact referring to the same thing. Everyone's familiar with the concept of an alias, right? Just in just general terms, I might have two names, right? One of my names is an alias. So, as an example, we will declare this function. So, who can tell me what this first bit means? I know you know. Doesn't return anything, thank you. Next, what's this word example? Yes, exactly. Example is the name of the function. And then what is this float val? Don't be shy.
Anyone?
Yep. Float val is a parameter, yep. And of course, this int ampersand ref is also a parameter. But the difference between val and ref is obviously that we've qualified the type with this ampersand. We're saying we want to take a reference to an int. We don't want a copy. So the float will be a copy, but this ref one won't. So that means that any changes that we make inside the function to ref will be seen by the caller when we return. Anything we do to val, they won't see because they give us a copy, right? That's all ours. Inside our function, we can do whatever we want with this. They won't see it. But this one's a reference. So we don't have our own copy. We're just using theirs. We're just using theirs and calling it by another name. So, as I said, the float is just what you're used to. It doesn't have that ampersand, so it does what you already know, what you're already familiar with. So let's have a look at an example of actually of using reference semantics. Yeah. So I'm going to have a function which we're going to call say hello. So you can see that as we went through earlier, right, we have a return, nothing to return, so we put void, the absence of something to return. We're calling the function say hello, and it takes one argument. So it's taking a std string, but we're putting this ampersand qualifier on it. We're saying we want a reference to some existing object. And we're going to refer to it inside the function as name. We're going to use that as the identifier to manipulate it by. So, simple enough. We can do name equals hello plus whatever name was already set to. So it's obviously going to now modify the contents of the string. And again, we're operating on a reference. We don't have our own copy. But it's going to modify that and put hello in front. Is that clear enough? Yeah. Yes?
So is the reference created every time that we create a variable, or only when we specify that we want a function?
So your function doesn't create anything, right? Because it's taking a reference. So whenever we call it, we must call it with an existing object.
So the reference, where is it coming from? Creating the reference.
So we're going to use this function now. So whoever calls it is essentially creating the reference. So in this particular case, we'll make a string called Tom. All right? That's all it's got in it. And then we will call the function with it. So now hopefully you can guess what's going to happen to this here when we call this function with it. Well, who wants to have a go at guessing? What's the contents of this going to be after the function call of Tom?
One thing which I think I'm feeling, when you create a variable, you're creating an object in memory, specific address of the memory. So the reference is just the address to that memory. So pretty much anything you create, like any variable, it will have automatically the address, so the system can find it. So I think that was your question.
Yeah, it's an alias. It's referring. This is merely referring to whatever you pass it. So in this case, it's going to refer to Tom, and so it's going to modify Tom. Sounds a bit weird when I say modifying Tom.
That sounds stupid.
Yes. So of course now when we print out Tom here, if we didn't have the function call at all, right, it would just print out Tom because that's what we set it to at the beginning. But we've called the function has operated on it and manipulated it. So this will in fact print hello Tom, because obviously it's modified the object that this refers to. Yes?
You explicitly pass the reference to Tom, or you have to put Tom very close, even though, like if you created a reference object.
Oh, so you're just to make sure I understand you right. You're saying, so say we have this std string Tom, yeah, and you're saying after that, but before, so in this gap here, this tiny gap, we then do std string ampersand Tom2 equals Tom. But when I say equals Tom, I mean this variable name here, not this string. Yes, then you could pass Tom2, and it would again, because you're just creating another name for the exact same object, right? So yes, even in here we can use this ref syntax, and we're just giving ourselves yet another name for exactly the same underlying object. Yeah. Your question? Oh, okay. So, very importantly, the reference symbol, the ampersand, is a part of the type, right? And everyone's clear on what I mean by type, right? Int is a type, std string is a type, etc. Vector is a type. The reference is part of the type. It's not part of the name. You know, I can call a variable Tom, but the ampersand is not part of the name. You can align it onto the side of the name, but it's still not part of it. It belongs to the type. So, for example, a float ref, right, this float ampersand, is a different type to just float. They are distinct. The compiler recognizes this. And for brevity, usually you refer to it as either a reference to a float, or really for brevity, when you're working with somebody, you'll just say float ref. They'll know what you mean, right? If I simply said float, it's that. If I say float ref, they know I mean the ampersand on the end. And obviously, they're very common in function parameters, as was demonstrated. They're very useful in that manner, right? I can give you a way to modify something that I have in a way that I can then see it after the function is returned back to me. Very handy, right? But you can use them elsewhere, right? So do we have? No, it's not. So you could use them elsewhere, as was pointed out. I could just declare a reference inside my inside the body of my own function and assign it to something that already exists. Potentially that's not as useful, right? If I've already got a reference, probably don't need to give it yet another name. I don't know, maybe you want to. And it does also combine with auto, as it happens. So obviously when you do, auto x equals 5, that's going to deduce to int. But if I put a ref on it, if I put this ampersand on the end, well, we're now telling the compiler, I want you to figure out the type for me. But once you've figured out the type, I want you to then ref qualify it for me as well. So for example, I could do auto ref. Let's just go back to the example to make it easy. So you've got something to look at. So I could take this std string Tom, and we could then have auto ref Tom2 equals Tom, and again the lowercase Tom, not the string. And it would deduce to a string first of all, but then it would see, okay, I put auto ref, so you don't want a copy of the string, you want a reference to the string. Okay, here you go. And that's the same as writing std string ref. You're just using auto to make the compiler figure out the type for you.
Does it become a jar star?
Sorry?
Does it recognize it as a char star?
Yes, absolutely. I wasn't saying on this string literal, I was saying on the name Tom here, the variable name, yeah. So, obviously, it gives us type deduction, and we get a reference into the bargain. Wonderful. But As usual, there are some caveats to reference semantics. So, firstly, as with any type that you can do something with, your function, or a function, could return a reference type. So rather than having a function that returns int, you could have a function that returns int ref, std string ref, whatever, right? If a function can return some type, you can certainly return a reference to that type as well. However, this can be extremely dangerous and cause you all manner of really nasty bugs, which is it's one of the beginner mistakes I see quite a lot. And you'll be tearing your hair out when you don't realise what you've done. So hopefully this will save you from it. So imagine that you're writing a function. You've just learned this really cool new reference feature of the language, and so within the function's code body, right? Everyone knows what I mean by code body, I assume. Yeah. Within that code body, you create some variable, right? An int, yeah. And your function then returns that value by reference, which means that the function's return type is declared as int ref. Inside the code body, you have int x equals 5, return x. So obviously, because the return type is declared as a reference, it's going to return a reference to that value that lived inside the body of the function. However, when we return from a function, any values that were created inside the body of the function go away, right? So we go into a function, it might create some stuff. Once we come back out of the function, all that stuff gets destroyed because it's no longer needed. Problem is, we've now returned a reference back to the caller to some object that we created inside the function, effectively an object that has been destroyed, been nuked. And the thing that makes this really, really frustrating and make you pull your hair out is that if you do manage to do it, literally anything can happen as a result. It might just work fine, right? You don't actually notice anything. At least initially, maybe then you start modifying your program a little bit more, and then suddenly it just happens to surface an unceremonious crash all of a sudden. Except you've spent 2 hours working and then only managed to just now materialize the crash. So you won't think to yourself that, oh, it's that bad thing I did 2 hours ago. You're not even thinking of it anymore. And this is what's known as a dangling reference. It's a form of undefined behavior, or UB. UB is this wonderful concept that we have in C++, which is essentially anything that will physically compile and will execute, but is nonetheless completely invalid, renders your program invalid, renders your program meaningless. The moment you execute anything that is undefined behavior, everything goes out the window. Your program has no predictability anymore. Yes? Question? Okay. So let's take a look at an example of.
Didn't you just pass it a reference to an existing variable? So why does it matter?
So the question was, or the statement was, what?
You passed a reference into a function, let's say.
So you pass an argument into the function by reference.
You pass an argument into the function by
Yes.
reference, and that is pointing to a specific place in memory. To an
And that
existing
argument is yes.
So why does it matter if that new variable inside the code function body has been destroyed? Because you've already updated the reference.
Ah.
memory.
So that's different. So if I pass an argument by reference, and for whatever reason the function chooses to also return by reference and returns that argument, which it took by reference. So I take by reference, I give by reference, yeah? If I just return that same thing, that's absolutely fine, because I receive the object and the object's lifetime is outside the scope of my function. I'm specifically talking about when I create the value inside my function and I return a reference to it. So we have an example. Okay, well, hopefully it will become very clear right now. So we're going to have a bad function. It's returning a reference to an int. It takes one argument by value, because it's not important in this case. So we're just taking one argument by value, which we're calling x. And then we're going to have our return value, right, which is simply just x plus 5. So whatever we give it, we just add 5 onto it, and done. And then we have this return ret bit. So would anyone necessarily think there was anything wrong with that? It just looks fine, right? There doesn't seem to be anything bad going on if you... Yes, question?
Sorry, there's something bad? I think there's something bad.
There is absolutely. There absolutely is.
The variable has been removed, so the scope of the variable there
Yeah.
is inside the function. When I return it, I think the compiler or the program thinks it's a different thing. So that memory address will be reused somewhere else, and that
Yeah.
can cause problems.
Yeah, precisely. So the problem is that we're returning a reference to a place in memory, a place in your computer's memory that will have already been freed. So in our main function, if we try and assign to, try and assign the value here, that's bad, right? By the time we return from this has all been cleared up. As it would happen, I would bet you that if you did run this, it would in fact probably give you what you expect. You probably would actually get 7, purely by chance, and the fact that it's using integers, and that the raw memory won't have actually been deleted, because you can't. Your computer's memory doesn't just get deleted, right? Your computer has the same amount of memory, but it's sort of shared between your application and the operating system. So that piece that it would use for this function most likely won't have been, or almost certainly would not have been given back to the operating system. So more than likely, even though this is bad, it would work.
Wait, why is it bad? Can't you use an int, or does it have to be inside the preamble?
So it's a dangling reference, right? By the time this function has returned, we have destroyed the object ret. So we've returned a reference to an object that we've just destroyed. So by the time it gets out, it comes back out of the function, and now we're trying to copy from the reference into boom, as I've called it. But that's dead. That's a dead object. We can't copy from a dead object. That's illegal. Yes.
What does unit start position?
Undefined behavior. About what, sorry?
Maybe it would be easier to explain that why is it destroyed is because of it being in
Oh, yes. Okay, sure. Yeah. Yeah, question at the back?
It's a good way to think about the problems that can arise if we use boom and if we return 7, oh, it's nice, but we do something else and we try to use boom again, and now it's something completely different because we've overwritten the memory.
So basically, so anything is allowed to happen, right? The program is essentially invalid. That could happen. That is entirely possible. Having knowledge of most contemporary PCs, if you built this as a program for your PC, more than likely you would probably get the right value in here. And using it subsequently would probably be fine as well. But legally speaking, your program is entirely invalid. And again, the reason why is that this object, right, this int ret, only exists while the CPU is executing the code inside this body. So obviously we call the function here, CPU goes into the function, this gets some memory allocated for it, we set it to x plus 5, then we're saying, okay, well, return a reference to it. So now there's, the return value is passed back here, referencing this thing which we've just destroyed. Because as soon as we come back out of the function to here, we destroy this, right? It goes away, we don't need it anymore. But we've returned a reference to it, a reference to something that no longer exists. It is what we call a dangling reference, and it is unusable. Makes sense? Yes.
I'll jump ahead. If you use an R value reference here, fine.
Nope, that would be equally as invalid. If you were to use an R value reference, because you would have to cart, first of all, you would have to, so everyone else just tune out for a second, because this is like getting more advanced. You would have to call stud move on the type here in order to return a ref. This is not for the beginner session. This is since he's jumping ahead. You would have to stud move this. You would have a dangling R value reference instead of a dangling reference, but you would have the same semantics.
Okay. Think of stud move. Yes, out quickly.
Okay, Tom's going to go into stud move.
Stud move is think every variable is a box. Yes, and you put box stuff, whatever you put. Yeah, so this is the box with numbers. This is box with letters. So if I put to box, let's say I name it Tom, I put there something. Yes, so stud move, it says I'm empty that box and I'm putting it somewhere else. So the box Tom is now completely empty. There's nothing there. It's nil. It's destroyed. Yes, make sense?
You've moved from one box to another, what I understood.
So, if you're interested in moves, I would word it in ways of saying that it's like a reference. It works a bit like a reference in that it has its own type, right? You notice there's ampersand for it. It's another. So if you think references are an extension to the type, right? I have an int. There is the reference extension, or I have a string. I can put a little ampersand. That's a reference extension for a string. So we also have the R value reference extension to types. So the reference extension and R value reference extension. But everybody else, don't worry about any of that. It's not important, not interesting. The thing to bear in mind is just that if you are going to return a reference in a function, then whatever it is you're returning basically needs to be some argument that you took by reference, which then sort of renders it a bit pointless. Now, they aren't completely, you might think to yourself, well, why would I do that, right? If I took a reference as an argument, what's the point of returning the same reference? Whoever's calling me already has that anyway. So the answer is that when we get into object-oriented programming later on and classes, then in that particular case, this becomes actually really useful and a matter of achieving good efficiency. So for regular functions and for what you're doing at the moment, you almost certainly don't want to be returning references in your functions. When you start getting into classes, you almost certainly will. But there's different rules that apply there. It's a different semantic, as it were. So we've got an exercise, and there was actually much less content than I originally expected. So I might have to throw something together while we do this exercise. Right. So in C-line, obviously, create a new executable, C++, of course, 17 if you like. And in your main.cpp file, write a function which returns void, i.e. doesn't return anything. Its name is increment and takes an int ref I, which will add 1 to that variable I. Then in your main function, call this increment function on a local variable, right? By local int variable, that simply means just to do int x inside main, right? That's all that means when it says local. And obviously print the result, and you should see that it directly modifies the argument that you've passed to it. Now try removing the ampersand, right? What do you think will happen? Try it, see what happens. Does it match your expectations? And then try calling increment. Obviously, put increment back to the way it was first. Increment with just 42 instead. Does it still compile? If not, why not? So, go for it. I thought that would take longer. He said he wanted to just do obviously auto and value times. I'll have to come up with one. I'll figure something out. But let me know if you figured it out. All right. No, that's not what I wanted. Sorry? There we go. I'm trying to edit in PowerPoint whilst also leaving that slide up, and it's not proving to be very cooperative. Oof. Let's have a look. No. Right, I'll tell you what I'll do, I'll just turn it out for a sec, and we can move the window across. Okay, that's good enough for now while I edit this. I already got one. I got a nice one. It's fine. Anyone need a hand? Yes, what you got? The function doesn't return anything,
Okay.
so you can't print nothing.
But are we supposed to?
Right, so just remind myself. So you've done that, yeah. Yep. So you want to print the result, right? So the result is not what the function doesn't return anything, right? So it's going to be what you pass to it. What did you pass to the function?
Like X.
Mhm.
This one.
Yeah. So you're going to need to break those lines up. So you're going to need to call the function first, and then print out x later.
To call the function first.
So you just call the function on its own. Yeah. But you want to print out x afterwards. Yep. That's it. Yeah. Carry on. What do you got? I see. Interesting. Oh, you're trying to.
Trying to break. Yes.
You're trying to break it. So.
And it works.
Yeah. So basically, that's what I said would be most likely because it's just an unwound stack variable.
Show them.
Sorry.
Just would be nice to show them.
So if you want a better way of making it all most likely break, try it with a std string ref. Make a function that returns std string ref. So a function that returns a reference to a string. Try it with that. That'll most likely do very weird things. Yes.
Because in the example we did,
Mhm.
you did Tom here, and then you did to print hello Tom, you just did Tom.
Nope.
And then when I sort of did the same thing of wanted to print my function call, then it just prints the one that I've assigned.
So yes. So your problem is that if you look at increment, you don't need to return anything, but the problem is you're creating a new variable, putting the result of I+1 into that new variable, and then throwing it away.
Okay.
So you don't want to create a new in this function. You don't need to create a new variable. You want to just operate directly on I.
Okay, so I get rid of this.
No. That's fine. You need that. It's just in the increment function, right? So you don't need to create any new variables. You just want to modify the argument.
Oh, okay.
So it's already declared. It doesn't need you don't need any type. It's already the type and all that stuff is already up there.
So if I just literally do
so
I+1.
Well, you need to assign it, right? So I plus equals or I equals I+1, one of the two.
Okay, got it.
Yeah. Yep. Perfect. Got any ideas of what I should cover next quickly?
By the way, I've researched a little bit, and I think I understand a little bit the story behind cryptography notation.
A what?
Do you know about ISIS Agora
Do I know what?
Do you know about ISIS Agora Lovecraft?
ISIS Agora Lovecraft. Luftcraft.
So you don't know. She's one of the. She used to be like for 8 years one of the co-developers of Tor. And she was
Okay.
one of the cryptography experts.
Okay.
She had a C implementation, which
Mhm.
was called Dollar, and then they started the Rust implementation, which was called Dalek. So the statement that Dalek is so fast came from a research project that they published in
Okay.
2017. It's benchmarking. Could be the environment, could be good luck. And to be fair, it wasn't always a clear cut. In some operations they were fast and others they were slow. But spread it.
What crypto algorithm? I'll get back to you. Yes. Where are you at? So you've got, yeah, that's looking good. Okay, so have you tried everything except the last bullet point?
No, I can't. This is the error it gives me. It says expects an owl value.
Yes. So you've basically done the last bullet point,
Oh.
which was to try. Well, now you found out it doesn't work at least. So.
Oh, so that's supposed to happen.
Yeah.
Okay,
So the last bullet
so
point
the
is
first
that's
bit.
expected. Yeah. So if the first bit, obviously we've got a variable there called num, right? So you pass that to the function.
Yeah, that's what I did.
No, you put 2 in there.
Oh. So it. Well, got it.
Yeah. There you go.
Okay.
And that's what you want. Cool. Every week. Have you been here every week so far? We haven't covered const yet, have we?
I was only here like last Tuesday, so I don't know.
Ah, okay. Does const mean anything to you? We haven't covered it, right? Yeah, we haven't covered it yet, right? Yeah, okay. I've got one more exercise then.
I think yeah, you should do the var, yeah. So either you write I plus equals 1, or in the other way.
One sec, I'll be right with you.
No, you can write plus equals, but you have to take out the
And okay. Yep, what's up? Got it working?
Yep.
Lovely, excellent. Yep, that looks good.
How it's supposed to work.
Yep, you got copies, got references. Excellent.
So that means if I understood right, we overwrite default condition or value from function
Mhm.
the container content.
Yeah, precisely. Yeah. It's effectively an alias. Yeah. Who's done it? Who's all sorted? 1, 2, 3, 4. Some still going. Okay. A few more minutes. I've got more. Well, I'm gonna introduce. I've got something. Don't worry. Oh no. You mean Grundkurz? It's a German C11 book. Yes, it's in German. You know, I was possibly going to go to. It's a Polish town near to. That's fine. It's a Polish town near to Bergogz. How do you say it? I can't remember the name, so I'm just. You know the one I'm talking about, right?
No, but ghost.
I think so. Do you know the airport code of the place? It's BZ. Anyway, it's near to a little town that begins with T, and I can't think of the name of that town. Turan, yeah, that's it. Yes, exactly.
How do you pronounce this? How to say my words that in our source to this Polish company with as our source to like all the town that is in
Yes.
I'm just, I get the gist of what is going on with the use of the reference.
Yeah.
It's not. I'm just
Yeah.
kind of wondering if you could explain a bit more. I understand that using the reference, if you you have a variable in your main, and say it's what, and then pass it to a function where your parameters are reference.
Yeah.
It's changing the parameter
Yes,
value.
because it's an alias, right? So your function is just referring to the same object but using a different name for it. So you pass it num, and inside the function it's now going to call it I. So it's using another name for the same object.
Right.
Whereas if you don't use the ampersand,
It
then you just
becomes a new object that's a copy.
right.
Yeah,
Right. So then I is then
it's just a
gonna
brand
be
new object
a
instead.
new object.
Yeah,
Right.
precisely.
But then why won't it work when you put in the number? I can't answer the why question.
Aha. That's one of the vagaries of C++ is basically that a reference must refer to something with a name, right? So, as in a name you've invented. So, you know, num is a name, right? That has a name. 42 doesn't have a name. It's not a named object holding the value 42. It's just 42. So you can't take a reference to that because it's not an actual value in memory.
So it's just a formality.
It's
basically.
so 42 doesn't exist, basically, is the way to put it. Your object called num is a real thing that you've named and it exists in memory, right? So it's a variable name that exists. But the number 42 doesn't exist. It doesn't take up any memory, right? It's just you're just saying to the compiler, okay, I have the number 42. But I can't take a reference to the number 42 because the number 42 isn't a thing, right? I can't refer to that. Make sense? I can refer to objects I've named, but not just like literals and stuff like that. Okay. Everyone good then? No one else need help?
Just hearing like all the rest of Polish words, it's super funny when you're Polish.
I mean, Tom is Polish.
Makes sense.
Yeah, no, I don't know what he's discussing with him now. I think it might be towns or something. What are you guys talking about?
Polish address.
Oh, he's teaching him how to do addresses. Okay, brilliant. I love it.
Yeah, I'm Polish with my surname, that's very so that doesn't sound. I was just wondering where hearing like when the Polish say like they yeah.
Yeah, let's do it. Okay. All right, everyone. So hopefully you all managed to get through that. If not, then I have the solution to your problems. Haha. So we'll have our increment function, right? The regular one takes a reference to an int, and it's using this really handy-dandy operator to add 1 to it. So you can just do ++ and then the name of the variable, and it adds 1. Super handy. You, of course, couldn't do it other ways. You could do I equals I plus 1. You could do I plus equals 1. It all does the same thing at the end of the day, right? It adds 1 to the thing. And then we've got, of course, our second version, which does not take a reference, but it does increment the local argument or parameter, if you like, inside its body in the same manner. We then have our main, and we'll create a value set to 0, right? It's called val. And we will then pass it to the first increment function, so we'll pass it to one at the top. And of course, as you'd expect, because it's taking a reference, this one at the top, it's going to increment it by 1. And since it's referring to this val variable that we've passed to it, it's going to modify it. We're going to see it, so when we print it out, we'll end up with 1 instead of 0. Makes sense? Then we'll call the second function, so we'll call increment 2. And of course, this one's taking a copy, right? It's not a reference, so it's going to copy the value into a new variable called I. It's going to increment I, and then it's going to throw that all away, come back to us, and val was never actually touched. So unsurprisingly, we still get 1. So obviously, this first increment does increment it, so it goes from 0 to 1. But this second one doesn't touch it, so it stays at 1 the second time you print it. And it's commented out because it doesn't work, right? The first one, increment, the top function, you can't compile this code by passing it the literal number 42. I can't take a reference to 42 because 42 is not an object. It's not something that exists and has a name. So it's fine for val because it's actually a variable with a name that's set to the value 42, right? So this thing is perfectly legal up here, up at the top of main. But this increment 42, which is commented out, is not at all legal because 42 is not a thing, right? 42 is just a number. I can set an int object to that number, but 42 in and of itself is not an actual object that I can take a reference to. Makes sense? Yeah. And then, of course, in the case of increment 2, well, it does work because all it's really doing is it takes 42 and then it initializes an actual object with it. So obviously int I is by value, it is an object. So therefore this second one, increment 2, does compile. It's completely useless. It's just as useless as the original, as the first increment 2, because nothing changes. But of course it will compile because it's just the value 42 is used to initialize the object that is the parameter, the argument, if you will. So hopefully that wasn't too confusing. Is anyone a bit lost or needs anything explained a bit better? Is everyone super clear why you can't, why this increment 42 doesn't compile and why the other one does? And why, or even just why the variable gets changed in the first case, not the second? Hopefully, yes.
Wouldn't it be a reference to the memory where the 42 is stored?
No. The problem is that 42 is just a number, right? You're expressing to the compiler, put 42 somewhere, but it doesn't occupy any memory. 42, the literal value of 42 does not exist as a piece of memory. Yes, it's not an object. If I took, oh boy, you're just spoiling it. But yes, so you are right though. If you do that, yes, no, it does. If you put const there, that will then work. Oh yes, I won't compile for that reason, but ignoring the increment, that would then work. Speaking of const, we're going to talk a little bit about the const keyword. Now I'm going to go over this very briefly because I don't know, or sorry, I do suspect that Tristan wants to go into it a bit more in depth. But as a general concept, I think it's time to introduce you to it. Also because it will feed in very nicely with references and a little exercise we'll have to round off. So, obviously in C++, right, sometimes we don't need to change a value, a variable, right? We want to read it, we want to look at it, but we have no intentions of making any changes to it whatsoever. And maybe if we have a function, it might be useful if the parameters of that function could indicate that they won't modify what you pass them, right? So that now means that another programmer who's going to use my function can see, well, you know, he's not going to modify that parameter because the code says so. Right? I know I can pass him something and it will be only read from and not written to. And as it happens, there is indeed a keyword in the language. So obviously by keywords, I mean things like int, float, auto. Well, now we have this new one, which is const. So the keyword is, again, part of the type, right? So in the same way that the ref, the little ampersand, is part of the type, part of the int, right? An int is not the same as an int ref. Well, a const int or const int ref is not the same as an int, right? You are adding a new classification to it. And obviously once you put this const on the type, it becomes read-only. So perhaps unsurprisingly, I can upgrade to const, but I can't downgrade. So if I have a const int, I can take a const int ref to it, but I can't take an int ref to it, because that would be saying that I want to take something read-only and make it writable. And obviously for safety reasons, it's a design feature of the language, You can't make read-only stuff writable. Once it's read-only, it stays read-only by design. So, if we do happen to try to write to it or otherwise make a modification to a const int, a const string, it just won't compile. The compiler will say, oh, no, you said that was read-only. You're trying to modify it. Not allowed. Can't do it. So, as a simple example, constant x equals 5 will be read-only after that point, right? So we're first of all creating it. So we have to give it, it's allowed to have an initial value of whatever we like. So it'll be set to 5. But then that's it. It's going to be 5 forever. You can't change it anymore. This obviously becomes very useful when you're dealing with references, because I can have a function that will take, a reference to a string or an int. And if I put const on it, I am guaranteeing that I will not change that value. I also won't need to copy it anymore. So imagine the case where we have this big vector of data, right? And copying that is slow and expensive. And I also don't want that data to be modified and mucked around with. Well, if I call functions that only take a const reference to my vector, they are not just promising me, guaranteeing to me that they're not going to muck with my data. They'll read it, but they won't modify it in any way, shape, or form, which is very handy. So, everyone understand the concept of const now? Because we're going to launch straight into another exercise. So it makes stuff read-only, essentially. And so, I want you to first of all create a function which takes a reference to a std vector of std string as the first argument, and a single std string as the second argument. The function should insert the std string into the vector unless the string that you pass has nothing in it. If it's an empty string, don't stick it in there. Then play around. See what happens if you add const to one of the parameters or both of the parameters. Try it. Next, I want you to create a second function. This one will take a const reference to a std vector of std string. So you got the little ampersand. And it will also take a const reference to a std string. So the first argument, std vector const ref. Second argument, std string const ref. And the function should only print elements to the screen that don't match the string argument that was passed in. So if I had A, B, C, D, E, F, and in the vector that is, and I pass B to as the second argument, it should skip B and be A, C, D, E, F. Simple enough, I hope. So finally, write some code in main to test out your functions. Yes, I noticed there was glasses at the back after all. Anyone completely lost? Hopefully not. is it going to mess with my... Oh, that was good timing, wasn't it? Give it a sec. Oh, you got it? Cool. Come here, off the screen. Right, better. Yeah, they did. Hmm?
Two things while you work. First one, if anybody wants to join us on Thursday for the workshop, please do RSVP, because tonight I will be closing it and you won't be able to join us. So we have 2 minutes time to do that. Second, is anybody could borrow Oli charger for a couple of minutes?
Has anyone got a Mac USB Type-C charger I can borrow for the remainder of the lesson?
Yeah. USB-C?
Ah, beautiful, thank you. Marvellous. All right, anyone need help? Yes, go for it.
Very stuck.
You're very stuck. Okay, let's see how far you got.
So I've made my function, put my vector in, tried to name it.
Don't. Yeah, that's fine. Don't assign it though.
Oh, okay.
'Cause arguments don't. Yeah, that's fine.
So I don't assign it.
No, you give it a name though. The name was fine, but that's there you go. Yeah, that's all good.
Does my ampersand go here?
Yes, that's correct.
Okay. I wish I could make it bigger, but it takes some time.
If you go to view, surely you can. No? Oh, I know where to go. Go to file and settings. That's yeah. And editor. Font. And change the size to whatever you want.
Ooh, okay.
Very readable. Okay, so so what you need to do is you need to give the function a body. That's all. So rather than these semicolons, you want curly braces like the main function, and then you can stick some code in there.
Okay. So I think, do I give string a variable name? Or if I give it variable names?
Yeah, well, you've given it a name. You've called it S,
Yeah,
but
called it S. And then I was trying to do pushback.
right.
So I would push my string back into the vector.
Yes, but that's a feature of the vector, not the string, right? Mhm. Yeah.
Then I would do my string.
Give it the string. Bingo. Except there's a condition where you shouldn't do that, which is in the yeah. You're very confused. Okay, what have you got?
As far as I can go.
Okay, so you've got your function, so it needs to have two arguments, right? So you've got one of the two, so you also want a body, so let's just give that some
If anybody
place
is
for some
stuck,
code.
raise your hand and we'll try to.
So first of all, you got a vector of string, which is correct, what we said there, right?
Right.
But you want it to be a reference, so what's the symbol for a reference?
Oh.
Yeah, perfect. But it needs to take two arguments, not one, right? So that's the first one, so then you want to do the std string as the next argument.
Another one.
A string, right? Just a string. Yeah. Give it a name of some sort. Yeah, cool. So then in the body of the function, it needs to insert it into the vector unless it's empty.
That's what I was trying to do here.
Mm-hmm. Oh, I see. Yeah. So just you can clear that away. That's fine. No, not to keep the closing curly brace. Just everything. Oh, it's done it for you. There you go. Just delete everything from line 9 and beyond. Yeah. Cool. Okay. So now you can write your code in the function that will add it to the vector, push it back into the vector, as long as it's not empty. Yes. Do you remember this from? Have you got any of your earlier work to look at? Yeah, that should hopefully give you a refresher. That's not the best example.
I have so many. Okay, so we're doing pushback.
Yeah. Oh, there you go. You got an example right there.
Yeah.
Yes. Mm-hmm.
So if you make it, the reason you can pass the value here, even though this text reference, because you've used const.
Yes. It's
So
a
what
special.
does it do?
It's a special rule that C++ has. So because it's read only, the compiler, the rules of the compiler say that it's allowed to create an invisible temporary object.
How's it different from const expr or expr?
So const expr is when you want to write some code or have an expression that is guaranteed, well, usually guaranteed, to be done at compile time instead of when the program runs. So it's a way of, I say, gaining efficiency, constraining your code to a particular point in time, a particular set of requirements.
So if you want to ensure that the value is going to
No
be
worries, hope you enjoyed it.
if you want to ensure that the value that's going to be used for that variables are always going to be this.
Yes. So for const, I might not know what it is necessarily until the program runs, but I do know that once I know it, I want it to stay that way. Const expr is when I know, as I'm writing the program, exactly what it should be, and I also don't want it to ever change.
Okay. And I've got one more.
Yeah.
Like I was trying to make this break. Right. I have something that returns an value reference, and then here I try and
Oh,
return.
but you don't get anything unexpected, right?
I was
Even though
expecting at some point I would expect this to like
Do
I
it.
thought that once you
It's because it's an int. Because it's an int, the memory is technically still there. Change it into, do it with a std string. Return, like, have the function return std string ref and std string ref ref.
okay.
And that's far more likely to do weird
And
stuff
if
and
you
blow up.
follow STD move, like it will always give you it always gives you the same address.
It's the same thing back. It's actually just casting the type to whatever ref ref.
So if I use something bigger, I might next time I call it I might get a different
No. So all it is a typecast. So have you looked up static cast yet? So all it's really doing is the compiler just says, right, I'll stop considering it to be a std string ref, and I'll consider it a std string ref ref. It's just a typecast. Yeah, exactly. Yes, fire away.
It's the vector.
You can't print vectors, right? You have to iterate over them. So that's your second function's job.
Okay.
Yeah. Having a go.
We call this function which I call reference closed. Saying no magic function to call. I just declare the string.
Return vectors to the string. Because it's a vector of references to string, which is an illegal type. You want a reference to a vector, not a vector of. Yes. No, not that. The whole type comes first, then you put your reference.
No magic function to call for reference.
Build it just to see. Oh. Oh, that's because. Oh, that's obvious. So it's because, like I was saying earlier, right? Your auto name is not a string. It's not a std string. It's a const char star. That was the caveat I was mentioning.
Oh, so you should never do auto for strings.
Well, you could use this what's it called, user-defined string literal operator in C++11, so you can stick an S on the end. But that requires a using expression. Basically, for now, if you've forgotten stuff, that does the job. How are you getting on?
We're trying to get this through. So would it be enough if I put here instead of the comma equals and then the curly braces? To
So
initialize
it
everything?
would, but that wasn't the point. The idea was you create two functions. So let's say you create one function. Yeah, that looks good. So rather than worrying about main just yet, I would do function number 2, because those two functions then give you everything you need. One of them will stick stuff in, and one of them will print it out.
I'm not sure I did this right.
Okay, no worries.
It both works.
That's good. No, so you're meant to have two functions, and then those two
Yeah.
functions do what you need. So the first one is the one that's meant to stick stuff in the vector. So you really just need to cut and paste a bit of code, basically.
That's
Well,
what I
fix
was-
the names. So, well, you need to fix the names up, but
Oh,
so the first function, right? You want to check if the string is empty first. If it's not empty, push it back into help, or whatever you want to rename help to. Probably something a bit more meaningful, but.
Okay.
So making sense, right? You want to shove it in the help vector.
I don't know.
So you've got the correct line of code there, the one that's highlighted in orange, but you want to put it in this utility function, right?
The 4 one.
So the idea is reusability. So we're gonna have we have these two functions, and then it gives us this a form of reusability, because we can keep calling that same function again, and it will do what we need. So no. So this one's just going to stick. This is the simple one. This is the easiest one. This one just needs to stick the string in the vector. So you have a string and a vector. You want to stick the string in the vector. Whoa, what's going on here?
No.
No, you've already got your variable, which you've called help.
Help. Yeah.
Yeah. So you just want to push back into that.
Okay. But what do I?
No. So what did you look what you did? Look what you did with the vector there. You got a vector there, right?
Yeah.
And this is exactly the same principle as the one down here. So you just want to push back into it. It just happens to have a different name. It's not called words.
Okay. So, but what are we pushing back into it?
The string was the second argument.
But I don't need to put it.
It's already the correct object. Yeah.
Okay.
So the only caveat you have now is you want to not do that if the string is empty. So you need an if statement.
Can't you do an unless, like with the exclamation mark?
Yes, exactly. So you can invert the logic. So if it's not empty, right?
Which
The string. Yes.
Wow.
Mm-hmm. Bingo. And then you just want to move the push back under it.
Oh.
So the conditional comes first.
It has to do that.
Yeah, the conditional comes first, and then whatever you want to happen or not happen comes after it. Get rid of the semicolon on the if statement. Otherwise, it just does nothing. There we go. So now that's conditional upon that if statement. Brilliant. So that one's good. Now you need to do function number 2, which is going to iterate over the vector. So it takes two arguments again, but this time it's just going to print them out.
Okay. So do we not have an int main at all?
You do have an int main, but you use that last. So create the functions first, then you're going to use the int main, and all the int main is going to do is the int main will call those two functions So you'll call the first function a few times to stick some data in your vector. So you'll have a vector in your int main. You'll use this one to stick some data in it, and then you can use the second one that you're going to create to print it out, right? So one's a writer, one's a reader. So you're largely building on the syntax of the first function. It's just this one wants const as well.
So how do I add constant to all of this already though? Like where
So you just you'll stick the word const in front of the type.
in front of the whole
In front of the type. It goes in front of each type. So you could have like const stood string.
every time.
You can have const stood vector,
And okay.
and don't forget the reference qualifier. Yeah, have it. Give it a go, and let me know how you get on. Yes.
So I've got those two functions that seem to work, but why this doesn't crash the syntax? So I've got a function push const, which take two const. One is a vector of string and the other is string. So
And it's a reference,
yeah. So if
but
I
it lets
have
you do it.
Yeah,
Yeah.
I've got PHP and Python, and first time I want to see what is not Python, which should print PHP,
Yes.
and this should crash,
No, it's
and
fine.
it doesn't.
Why did you think it would crash?
Because that's not a variable, so it can be a reference.
Right. So it's not that it would crash. It would, if you took away the const, it wouldn't crash. It would just not compile. It wouldn't build. So when it's const, there's a rule in the language, a special rule in the language, is if it's a const reference, because it's a special read-only value, it's allowed to create an invisible temporary that you can't, that just magically exists for as long as it needs to. It creates an implicit temporary, which is only because it's read-only. The moment you take away const, so if you just had a regular reference, that then refuses to compile because it makes no sense to create something that's going to be written to that's temporary and will go away. So for reasons of sanity, it doesn't work on a regular reference, but it does work on a const reference. So it's actually constructing a read-only string temporarily for you, which is fine because we're just reading from that data. It's efficient, right? So that's why it compiles. Yes, question. So let me pop. That's the best way to get through. Try around this way. Or I'll just lean over. Actually, go on. Right.
So I built these ones over here, and then when I'm trying to read out this vector, I keep getting the eyes are all red. And, if I change it to vector, I make
So-
I an integer. It does something else.
So I would recommend using a range-based for loop, but if you want to use the old style, your first problem is you haven't given I a type, so it doesn't know what I is. So the two ways to fix that is you can either use int or you can use auto,
Okay.
whichever one you prefer.
Since
And-
it's non-static.
And
there's
no, so size is a function,
yeah.
but you're not actually calling it, because to call a function we need, yes. So just put auto I or int I, whichever you prefer, and that will fix that problem as well.
Okay.
Cool.
You always have to put it at the top, right? Before you
Sorry, what?
auto I. You should put it at the top, not in your.
No. You definitely don't do that. You just want to put it where the I is. You need to put it in front of I. That's all.
Oh, okay.
The first one.
Okay. Oh yeah, it wouldn't be registered inside the function.
Yeah, it's not declared. Yeah.
Yeah, wouldn't be.
No, not there.
There.
No, you can literally just do it in the for loop.
Really?
Yeah.
Okay.
And that part of the for loop is designed for initializations. No. Just no. You already have the I. Just all you need is the word auto. There you go. Done.
Is it possible to tell me whether this page got writing on it, and you give me a box, and I'm telling you like, oh, hold on, you give me a box.
Yes.
I wanted to understand the error messages.
Mhm.
Obviously, I know
Okay.
what's going on and why it doesn't work. Made only this const, the vector I'm passing.
Yeah.
But I just want to understand how to read these IDs.
So it's saying
I've never
error.
read them.
Yeah, it says it's passing. Right. So you're passing a const object.
You can call vector.
Right, but then the arrow is pointing to where you attempt to push back, which says you discard the qualifier.
What does that mean, discard?
Well, it means that pushback is not a valid method, not a valid function call, when it's const, because obviously pushback modifies it and it's read-only. It's not the, it's honestly not the most readable of. Yeah, what compiler are you using? GCC or Clang. So depends what you install. So I would say if you had the latest Clang, it might give you a more helpful error message than some of this more esoteric. Yeah, it's a bit esoteric, yeah. Who's done it? Okay, excellent. Good. Okay, you're getting closer, don't worry. You're sort of. Okay, so actually, wait, you got a couple of problems. So this doesn't need to return anything, so I missed that, sorry.
Oh.
So that doesn't give anything back, so it's not needed. That doesn't either, so void. Then you obviously need the curly braces, so it's got a body. I was got a little bit confused, didn't it? So stop. There we go. Right. So let's see. You've got. Okay, that's an interesting way of writing it, but that's legal. That is legal. You can do it that way.
Can I?
You can. I mean, you could have just stuck const at the front
I
though to make it.
myself a little bit there.
Yeah, it lets you do it at the end, at the beginning or the end, but just for consistency, right? I think this is the most readable way of expressing it. So it's a constant vector of strings and it's a reference.
Yeah. Okay.
So you've got A and B, and then what we need to do basically is you need a for loop to go over all the elements in this thing, and as long as it doesn't match that one, B, you can print it out. If it does match, just don't print it.
So I had 4.
Yeah.
Not B.
Oh no. So a for loop is designed just for going over it. So all a for loop does, a for loop will just go over each element. As you're processing each element, you can then have a if statement to check it or whatever, right? So first you want to do a normal for loop iteration, right?
Okay, so I have to do the name.
So you need the type and the name, or you can use auto like you've just learned if you want. Yeah, and then what you call it, a name or.
And then.
So no, it needs to have a name, right? So this is representing each element that you're going to iterate over. So do you, don't use the same names as your arguments. It won't stop you, but it's going to get messy. Yeah. Okay. And then no. So then you use a range-based for loop, right? So you can use a colon.
This one.
Yeah. And then the vector you want to iterate over, which is B. Right. So now it's going to go over every string in the thing as many times as there are, and for each one, X will represent like the first element, the second element, the third element, the fourth element, right, until it runs out.
Right. So we have to say it.
So now you need to check if. Oh, sorry, it's not B, is it? Sorry, it was A. Yeah, perfect. There we go. That makes more sense. Now you want to compare it, right? So if it's not the same as B, you can print it. Yeah. No, there's a simpler way than that. So how do you express doesn't equal? So what was the syntax for equals? To see if two things are the same, right? What's the inverse of that? Did we cover that?
I don't know.
Oh, it's exclamation mark and equals.
I didn't know.
So not equal. Okay, so now you just need to compare the two sides, right?
B.
Yeah, so B's on one side.
What do you mean on one side?
Well, when I do a comparison, I need to have two things to compare, right? At the moment, all you've written is B. So nothing doesn't equal B. Right?
I'm so
So what element is it using? So you're looking at each element individually, right, in your vector.
Oh yeah, we're getting over time.
You've got a vector with X, like two elements.
So X is the element.
Yeah. Do you understand it?
Yeah, so you can compare, so you're looking, is X equal to B? So is X not equal to X is not equal to B?
Then you can print it.
Okay.
So if X and B are different, so you want to put X in front of the not equals.
Yeah, that's like not equal, it's like a operation.
X doesn't equal B. There you go. Right, I think we're getting close to time, or running over. We've run over, in fact. So I will very quickly. Or actually, who's done it? Who wants to do it as homework? Who wants the solution now? Okay.
Oh, no clicking.
Very quickly. Very quickly. Okay.
You need to turn around or close your eyes.
Or maybe we're going to have to call it because I think PowerPoint might have crashed. Oh dear. We've got troubles. All right. You know what? I will leave it for Thursday because